I would like to introduce you to Tim Davies from University of Canterbury, Charlotte Krautschik, who is also the convener of the scientific session connected to this event, from what's that? University of Leibniz Institute in Hamburg. Bill Fry from Lower Hutt, New Zealand. Caroline Holden from Lower Hutt, and Philip Griffiths, who is the ambassador of New Zealand in Austria. I think, Charlotte, you will start an introduction and we'll carry on.
Yeah, thank you, Dick. Good morning, everyone, and a warm welcome also from our side. Together with Mary Fowler from Royal Holloway in London and me, we tried to put together a symposium on very short notice on the important events that happened in New Zealand with the Christchurch earthquakes last year and this year. And we want to discuss with you with this panel consisting of scientists and, for our great pleasure, also the New Zealand ambassador to Austria, Philip Griffiths. We wanted to discuss with you all the questions that may arise about the earthquake and the processes taking place themselves, but also to discuss what will be the next steps for science, for outreach, and all that might be of interest for you to further communicate about these important geoscientific events that are currently taking place. So what we would like to do in the next minutes, firstly, is to introduce ourselves, just to give the names, the affiliation, and also the main area of expertise, so that you have an idea whom to ask for what kind of topic. And my role will be to keep the thing a little bit running, direct the questions to the right persons, and these kind of things. So perhaps to start off, my name is Charlotte Krautschik. I'm at the Leibniz Institute for Applied Geophysics in Hanover in Germany. My main research is dedicated to controlled source seismics, but of course as division president for seismology at EGU, I'm familiar with this business and try to spread these informations around. So I start to my left with Tim Davies.
Yes, I'm Tim Davies. I'm from the Geological Sciences Department at University of Canterbury in Christchurch. I experienced both earthquakes. I was about 10 kilometers from the epicenter of both. My main interest in these events is in trying to anticipate the ongoing seismic and rockfall hazards. I'm the leader of the Hazard and Disaster Management postgraduate programs at University of Canterbury, so have a deep interest in preparation for hazardous events and in trying to reduce the impact of future hazardous events by, for instance, land use planning and thinking seriously about the way society behaves in hazardous circumstances to become more resilient and less vulnerable.
Okay, Bill Fry.
I'm Bill Fry. I'm a research seismologist at Geosciences. It's the national funded agency that's in charge of looking after natural hazards in New Zealand. I'm happy to answer questions on the earthquake process itself. I look at the way the earthquake happened and then the way the waves traveled from the source of the earthquake to reach the town. I'm also happy to answer questions about what we did in the first hours after the earthquake. I had the bad fortune of being on earthquake duty, which means that we have a rotating shift where a seismologist will take a week of duty, and they're in charge of looking at all seismic activity. There are about 8 of us that do it, and I happen to be on that afternoon.
Again.
It's a bit of a recurrence, yeah.
All right, so good morning. My name is Caroline Holden, and I'm a seismologist at Geosciences, colleague of Bill. So I look at source rupture process of large earthquakes, and I've done my PhD in Christchurch, so I was a bit familiar with the surroundings in Christchurch, and I was privileged to go back 2 weeks ago and was quite shocked by the site I was going through. And also I've got a little bit of insight into the Earthquake Engineering Society. I'm on the management committee, but acting as a seismologist, just feeding information to the earthquake engineers. Thank you.
And I'm Philip Griffiths, New Zealand ambassador to Austria. I'm very grateful to the Europe Geosciences Union for and to Mary and Charlotte for organising this event, which I think is an important part of sharing the experiences and learning the lessons from the disastrous event in Christchurch, and also the events in Japan. And our thoughts are certainly with the Japanese people as they deal with the disastrous effects of the earthquake and the tsunami on the 11th of March. For the residents of Christchurch, this was a devastating event, obviously causing loss of life and a great deal of damage. The New Zealand government has a high degree of earthquake preparedness and a ready response mechanism, and all the systems sprang into action. First of all in the immediate rescue and recovery phase, then in supporting the businesses and the people of Christchurch, and in restoring essential services. And in the 6 weeks since the 22nd of February earthquake, a great deal of progress has been made, and the institutional arrangements have been put in place to coordinate the ongoing recovery and rebuilding effort. International assistance has been critical in New Zealand's coping successfully in the immediate aftermath anyway of this event, and we're very grateful to our international partners for all the help we've received. I think this seminar is demonstrating that the progress that has been made also in the scientific understanding of the event and the lessons that we could learn in the future. May I just say that there's a high degree of earthquake engineering in New Zealand, but the severity of this event has given us cause to reflect on our building codes and standards, and a Royal Commission is investigating why buildings performed in a certain way in this extreme event and how the codes and standards can be strengthened for the future. Thank you.
Okay, so this is somehow the panel you're facing. You see, except me, these are all colleagues and experts from New Zealand itself. So yeah, please be free to ask about the rupture process, the earthquake itself, and any kind of things you would like to ask.
As I read in your handout, this earthquake was very extraordinary. Yeah, my name is Heinz Jagd from the Austria Press Agency. As I read in the handout, the earthquake in Christchurch was extraordinary because this area is not known as very active in the underground. So do you think that this event should have an impact to the recent discussions about atomic energy and the atomic power plants?
We certainly need to understand the probabilities of ground shaking whenever we put in any sort of critical infrastructure, I think, whether it's an atomic power plant, whether it's a hospital, whether it's a school for children. So from that aspect, yes, we need to understand, especially in a place like Christchurch now, that maybe our estimates of probabilities of earthquakes or ground shaking do change, and we need to update our probability forecasts with all events we have and make planning decisions based on those.
Tim, would you comment on that?
Yeah, I'm not sure that nuclear energy is a critical issue in New Zealand. We have a fairly long history of not indulging in nuclear energy. I think a far more urgent question, which relies on better understanding the seismicity of Christchurch, is the question of what should be done with the many, many properties which have been damaged by rockfall and landslide. We need to understand what the future hazards are for those sites in order to decide whether those sites should be abandoned or reoccupied or strengthened. We would very much like to have hard and fast scientific evidence on that. I don't think we're going to get it. So some quite difficult judgments are going to have to be made, which again will be informed by the improved probabilities, and will also be informed by the fact that this event in Christchurch did happen, and therefore can happen again. But we don't know when.
Anyone else?
So can you tell us what was extraordinary on this event? I'm no geologist.
There were a lot of extraordinary things from the physical aspect. Other people are much better to comment on the building aspect and the built environment. But from a rupture process, it was quite exceptional, and that it was the energy was actually directed, focused quite efficiently toward the town. The earthquake broke at such a speed that as the earthquake rupture was propagating up this slope, it was energy that was released during the first part of the earthquake was stacked with energy that was being released as the earthquake continued to rupture. So it meant quite a bit of energy came as one consolidated packet into the city.
The proximity of the earthquake also is a major factor. The fact that the city center was only 8 kilometers from the epicenter, and the shallow depth of the hypocenter are major factors. Is a major factor as well of the intensity of the shaking. Yeah.
We also see an effect that is analogous either to someone jumping on a trampoline or maybe jumping on a trampoline and getting out of phase and slapping down against the trampoline quite hard. So when the energy was coming up through the sediments that underlie the city, there was probably some sort of differential movement between layers of the ground. And when you get this differential movement, you get either a separation or a change in the physical properties between there, maybe a decrease in the amount of pressure at the interface. And that means that the two layers move at different rates. And when they come back together, it's slapping and it's sending a lot of energy in the vertical direction. So this made it particularly bad too.
Could I comment as well on the extraordinary aspect? I've lived in Christchurch now for 35 years and was very happy until September the 3rd, 4th last year that major earthquakes didn't seem to happen in Christchurch. Then suddenly, quite out of the blue, a major earthquake was felt in Christchurch. That to me is extraordinary. And in the seismic history, the known seismic history of the area, that's also extraordinary. And the lesson that I take from that is that in an area of known seismicity like New Zealand, you should really expect an event of this type anywhere, anytime. Now, what you do about that in terms of running the country, I'm not very sure. It makes life quite a lot more difficult.
Hello, I'm Dagmar Rödig for the German radio station Deutschlandfunk. Is it possible somehow to detect hidden fault system by geophysical methods to get a better feeling of what is possible and to make better paleoseismic assessments?
Want to address it? Yes, it is possible. So there are actually a number of ways we can approach it. So in a typical situation before February or before September of last year, before we had this earthquake, you can do things like gravity surveys or seismic surveys. Actually, you should address this also. But one fortunate outcome of having an earthquake, and I would never say it's fortunate to have an earthquake, but we have a rich aftershock sequence. So as you see in the back of this handout, there are lots of aftershocks that follow particular patterns. So typically after an earthquake, you get aftershocks that radiate out from the edges of the plane that ruptured. And then stress actually goes from the surface that slipped originally onto other faults. And other faults can be triggered, and you can have earthquakes on other faults. So by precisely locating these aftershocks and looking at them in a very analytical way, then we can say something about other faults that are actually active in the region too that we never knew about before. So the aftershocks themselves will highlight where other faults are.
Caroline, you want to comment on that too, or?
No, just to say that yes, there are many geophysical techniques that allows you to characterize the ground that's hidden from the sediments. But again, I'd like to emphasize that New Zealand is a small country, and these campaigns cost a lot of money. And unless you have a good reason to do them, which is usually oil exploration, this type of research is not really, is not a priority. So, yeah, it would have been ideal to have a whole map of the Canterbury Plains, very detailed, prior to the earthquake. But yeah, we're fortunate in Wellington. There has been a recent campaign working in the Cook Strait, looking at mapping active faults in the Cook Strait that are potential hazards for Wellington. So this type of research is happening, but yes, not as much as we would like to.
What one could do also, in addition to the seismological events depicted by the aftershock sequences, is if you have, for example, a geological survey in an area and you have a kind of model. This model usually gives you an idea where could be some fault structures, because depending on what you find as layers and fault structures in the subsurface, you have some mechanical possibilities how the subsurface may behave. And some of them can be excluded because it doesn't work physically from the mechanical side, and others have to be tested. And if you are that far in your science, then you can, for example, do controlled source seismology to image the structures in the subsurface at areas where you may think there may be a blind fold below the surface that may bear some potential to be active. So that's also one reason to have here at EGU different scientists together, because we have to work from the surface towards depth and to connect all the different aspects our specialties reveal us. So, for example, we have paleoseismology and trenching to give us a record about paleoseismology. We have the active methods to see what is the status today. And we also have from geomorphology important indications for that what's going on in a larger area. So we have to go both from surface to depth and also from the overall view to very localized spots to depict the areas of danger.
Yeah, I could perhaps add that over the last 20 years, there has been a program of investigation run from University of Canterbury on active faults in the Canterbury region, which includes the Canterbury Plains. Just after the September earthquake, a paper was published reporting one of these investigations, a geophysical investigation specifically looking for faults in the Canterbury Plains. Unfortunately, the area it covered didn't quite extend as far as the Greendale fault, which ruptured in September. But from a general point of view, we know that in the eastern Southern Alps, there are many faults in the Greywacke rock. We know that the same Greywacke rock underlies the Canterbury Plains, so in principle one should accept that there will be many faults underneath the Canterbury Plains. But I'd also like to make the point that simply locating a fault doesn't tell you how active it is or when it last ruptured or what its history of ruptures is. I think underground or geophysical paleoseismology is quite difficult, probably. There's a project about to be proposed to look at the history of boulder falls in Banks Peninsula, just to the southeast of Christchurch. There are many, many boulders in the bottoms of valleys. And if we can date the occurrence of those boulder falls, we may find that these dates cluster, and the fact that they're clustering at certain times in the past may indicate that there may have been earthquakes at that time. And to me, that's one of the best approaches to establishing the paleoseismic history of the Christchurch region.
Are there any connections, maybe seismic or geological, between the New Zealand earthquakes and the disastrous earthquake near Japan?
From a very broad-scale genetic perspective, yes. They're both caused because of convergence of the Pacific plate westward. In Japan, it's converging against the Asian plate. In New Zealand, it's converging against the Australian plate. But other than that, it's really hard to draw a fast scientific connection between the two.
So you would say the events are not connected?
I would, yes.
Mm-hmm. Yeah.
Yeah, the size of the events are quite different. The Christchurch earthquake and the Darfield earthquake would look like a tiny dots compared to the 500-kilometer rupture of the Japanese earthquake. And the type of mechanisms are quite different too. The Christchurch earthquake is a crustal type earthquake, whereas the Japanese one is a typical subduction mega earthquake. So certainly the Christchurch didn't influence the Japanese one.
What might be argued for by some people is that the 2004 Sumatra mega earthquake actually is somehow genetically related to all of the large earthquakes we've had since. But this is at present quite tenuous, cutting-edge research.
Dagmar.
After this experience, are there efforts going on to strengthen buildings in other parts of New Zealand because there might be something similar?
I guess the hotspot of earthquake activity previously to Christchurch was Wellington, and so all the Wellington has the highest building standard in New Zealand. Christchurch did have a very high building standard, and I have to insist again, all of the modern buildings didn't collapse, didn't even get any damage. So the building code is really, really strong. Now it's going to be revised anyway because all these earthquake-prone buildings that were in Christchurch did get damaged, and the policy behind reinforcing those buildings is that they have to be at least up to 33% of the building code, the actual building code, and obviously this is not high enough. So there's a lot of changes that will have to occur in the New Zealand building code for Christchurch. Now, I'm not familiar with other. I guess the major cities in New Zealand are Auckland, Wellington, and Christchurch. So definitely these ones were the focused for earthquake engineering research. But yeah, I can't comment on the other cities around the country.
Could I perhaps add that if the building codes and standards hadn't been so high in New Zealand, an even greater loss of life could have been expected. But this event has led to the establishment of a royal commission to investigate the reasons for the behaviour of the buildings in Christchurch, why the impact was so severe in some cases, and to come up with recommendations on strengthening the building standards and codes. And they have quite a tight time frame to report back. In addition, a panel of experts has been set up to look at the most badly affected buildings in Christchurch, a small number, and to investigate the reasons for the way they performed in the earthquake. So that there are quite a lot of institutional arrangements in place, also drawing on the scientific findings and ensuring an integrated cross-agency response, both central government and local government in New Zealand. Thank you.
Thank you. My name is Sonny Burgan. I'm a freelancer and I'm writing this article for Wiener Zeitung. Yesterday I had an interview with Emil Okal, about the earthquake in Sendai, and he's mentioned that one of the very interesting, as a very important point for him, is the education of the people. My question is, this is you said what happened in Christchurch was an extraordinary event. So my question is, were the people best prepared for that, or was it so strong that it surprised everyone, and that in effect the people weren't prepared for that as well as could have been possible?
I can make a start on that one.
Yeah.
In the late 1990s, New Zealand geologists first got a clear picture of the seismic threat in the South Island posed by the Alpine Fault. This is the major plate boundary fault on the west coast of the South Island. And since then, quite a lot of work has been done to estimate the degree of shaking in places like Christchurch, which can result from the Alpine Fault. And in the last 2 or 3 years, a colleague at GNS and I have been making a series of presentations to a large number of groups all around the South Island. And in particular, in Christchurch itself, I've given half a dozen talks to schools and adult education organizations and so on about the likely impact of an Alpine Fault earthquake. And I believe that some of that information has probably been quite useful in preparing people for what has happened in Christchurch. Certainly the degree of shaking that's occurred in Christchurch is far greater in intensity than one would expect from a far distant Alpine Fault earthquake. But certainly some of the effects would have been similar. So to that extent, some people in Christchurch were increasingly aware that there was going to be a major earthquake. It turned out to be the wrong earthquake, but hey, an earthquake's an earthquake.
I think it's fair to say that there's quite a high level of earthquake awareness in New Zealand. People know that New Zealand is prone to earthquakes, and our Ministry of Civil Defence and Emergency Management runs a public education campaign directed to both communities and individuals. This consists of media campaigns, public relations and promotional activities, and resources for schools. So it's fair to say that there's a fairly high level of awareness of what to do in an earthquake. But of course, this can always measures can always be improved and strengthened.
If there are no more questions, then I would like to thank you very much for your introduction and answering the question.
Thank you.
Thank you.
Thank you.